everyone! Chapter 7 Quadratics. This is Learning Target 3. This is Miss Osier.
And Miss Lahar.
And here we go. So last time we had to pause and be like, okay, it's going to be fine, guys. We're going to get through this. This time, you know what you're doing.
Yep. This learning target, even though I didn't crop it up there, is I can completely factor, completely is the main keyword, and solve a quadratic equation.
Now, we're focusing on this completely word here because usually that's a hint that you can do more than one thing. So we always check for GCF first. Hey, guys, this has a 4 in common.
Yep. Always GCF. Look for something that you can take out of all of the terms.
GCF.
And then it makes your life easier because now we, easy trinomial, factors of 10, subtract to give you 3 or 5 and 2. You could do factor by grouping in that method if you needed to. Okay, we just kind of skipped ahead on that because, that is completely factored.
Look at us go. B, 6 in common.
Ooh.
X squared minus 4. Because it's a binomial, I check for difference of perfect squares. This is, in fact, a difference, and x squared and 4 are both perfect squares. Bam.
Completely factored. All right.
GCF.
GCF. You can take out a 2. Factors of 25 that subtract to give you 10 are... Wait a minute. Oh, that should be a positive. That's a typo.
Oop. Plus.
I was struggling. I was
That's
like,
okay.
there's no...
Nope,
that should be a plus, and then it's going to be...
5 and 5.
Yep. That's right.
That's a plus right there. Plus.
Oh, chalk it up to a last. Number D. Number D. Yep. Letter D. Take out a 3. And I went southern on it.
Difference of perfect square.
5 plus x and 5 minus x.
Now, it's okay that it's whatever because you guys know how to do this. We even spent like 3 days before, Christmas break, making sure that you knew how to do this.
Yep. Ooh, that was it. You could write it like that.
Fancy.
If you wanted to.
Fancy.
Okay.
All right, completely factor. Here we go. Check for GCF.
5.
It's not 10, it's 5. Very good. Not like you didn't know that. I'm saying it for them.
2 times 21 is 42. Factors of 42 that subtract to give you 11 or 14 and 3. Factor by grouping.
Bam.
So I take it out. Oh, look at that. Separate.
Bam.
Now, please do not forget this. Well, we took out a 5. You can't just like disappear.
No. He's still there.
He's still there. Bring it down.
Why he's a he, I don't know, but he's there.
Yep.
Right there.
Ooh, God, 4 terms.
Okay,
and those
anytime
are big
there's big numbers, I always check the smallest number. So I would first check 32. If 32 didn't work, I would check 16. If 16 didn't work, I would check 8.
I would look at 32 and 56 and notice, I think 8. Yep. They both have 8 in common, so try that, and then that looks a lot nicer.
Oh,
now you factor by grouping.
Oh, yeah, just kidding. It's a 4 term. Look at this go.
I ignore the 8 when I go to factor by grouping. I do the factor by grouping, and then I remember to put the 8 back, but some of you might need to bring that 8 down the entire time. You do you. Just don't forget about them.
Circle them, whatever you got to do. Circle them and make an arrow and be like, don't forget that comes down.
But look at what we're working with. Are we completely factored, Miss Osier?
We are not completely factored, because remember, every time you get to a step in factoring, you check. Okay, monomial done. Binomial. What's the only way I can do binomials?
Difference of perfect cubes or squares.
Ooh, that's right. We have that now. Difference of perfect squares. And then this binomial, definitely not difference of perfect squares.
So you can do it one more time.
So we go. Hold on.
Oops, animation.
2x minus 1, 2x plus 1, 4x minus 7, and the a is on the outside.
Yep, that is completely factored.
Now, what are we going to do with all these factors? Well, just like in, polynomials, we're going to solve them.
Yep. So we got to remember the good rule of the zero product law. I bet you didn't know it was a law, but basically if something is multiplied to give you 0, one of the factors has to be equal to 0. So that's why when we solve these, we set each piece equal to 0.
Because anything times 0 is 0. Therefore, every piece is a solution.
When solving a quadratic, you always get the equation equal to 0.
Check.
Get everything over to one side. Always factor with a positive leading coefficient is good advice. And then factor it. Now set each piece equal to 0. You've done this in algebra. You've done this probably in geometry.
We've done it in polynomials. We've done it.
You should be thanking us for putting this in this chapter. Oh, look at me do it all at once. So just get everything over to one side. You factor by grouping. And then you factor, and then you set each piece equal to 0.
We're clicking quick because this is review. You should, this is review.
So now you can pause and just, write all that beautiful math work down with correct notations and stuff. But anyway, that's it.
But that's it. It's what we've been doing. It's what you continue to do. Have a wonderful day. We will see you in class.